Two flasks containing two different gases are connected by a closed valve. What is the total pressure in the system after the valve is opened? So to answer this question, we are going to use Dalton's law of partial pressures. Dalton's law of partial pressures says that if you have a mixture of gases, that the total pressure is equal to the sum of the partial pressures of those gases. So each gas is exerting its own individual pressure, and however many gases you have in the system, if you add up their partial pressures, that will equal the total pressure in the system. It doesn't matter what the identity of the gases are, how heavy they are, their molar mass, none of that matters. It's purely based on their partial pressure. So we have two gases here, nitrogen monoxide and oxygen gas. They're separated by a valve, and when we open that valve, they're going to be allowed to mix together. So the temptation is just to say, well, the total pressure is simply going to be the sum of the starting pressures, which is 1.23 plus 0.84. However, we can't do that because as each gas is allowed to expand into the other container, its pressure is going to be dropping. And so the partial pressure of both gases is going to be lower than the starting pressure because they are expanding into a larger volume. So the way that we're going to handle this is we are going to use the equation that we've used before, P1V1 equals P2V2, to find the final pressure of each of the gases after the valve is opened. So starting with NO, our starting pressure is 1.23. Our starting volume is 0.54. The final pressure, which I'm going to call the pressure of NO, is what we're trying to find. And the final volume is going to be the sum of the volume of the two containers. 0.54 liters plus 0.14 liters. And if we solve for the partial pressure of NO after we've opened the valve, we get 0.98 atmospheres. So you can see that we went from 1.23 down to 0.98 because the gas was expanding into a larger volume. Volume and pressure are inversely proportional, and so the pressure went down. Next, we're going to do the exact same thing for O2, starting with the beginning pressure of oxygen, which was 0.84. And the starting volume of oxygen, which was 0.14 liters. We're going to find the final partial pressure of oxygen in its final volume, which is the sum of the volumes of the two containers. And for the final partial pressure of oxygen, what you end up with is 0.17. Now we're going to use Dalton's law. So Dalton's law says that the sum of the partial pressures equals the total pressure of the gas. And so we're going to take the partial pressure of oxygen plus the partial pressure of nitrogen monoxide, which we just found. So it's 0.17 atmospheres plus 0.98 atmospheres, and what you end up with is a total pressure of 1.14.